So, hi everyone, and thank you for being here today. In this presentation, I would like to talk about optics. Optics are often described as being the equivalent of jQuery or XPath, but for all immutable data. So with such an impressive comparison, you would expect optics to be very popular, right? Well, this is the case in Haskell, for example. But in Scala, we rarely see optics in real-world code bases. Why is that? Why are optics not popular in Scala? Today, I want not only answer this question, but also offer some solutions to the current problem. So let me introduce myself. My name is Julien Truffaut. I'm a Scala backend developer, and I also teach functional Scala at Afp-tower.com. I recently released an online course that focuses on the practical side of functional programming. And if I have time, I would like to say a few words about this project at the end of this talk. Now, the most relevant aspect for today's presentation is that I'm the creator and one of the maintainers of the open source library Monocle, which implements optics in Scala, and it's part of the type-level ecosystem. Okay, so what is the agenda for today? First, I would like to talk about optics, about what problems are they trying to solve. And to do this, we'll go through a few realistic examples that I'm pretty sure you're all facing in your code base. Then I will give a quick introduction to optics, what they are, and the most important parts of their API. But this section will be very brief. Finally, I will present two problems with the current version of Monocle and how we intend to fix them in the future. Does that make sense? Okay, great. So I don't know about you, but when I learned programming in languages like C or Java, pretty much all data structures were mutable. We can replicate the same behavior in Scala by creating a couple of case classes where all the fields are marked with var. So for example, here I created the class user containing a name and an address. And address is itself a case class with a street number and a postcode. Case classes are extremely convenient because we can access the data inside them using the dot operator. For example, we say julian.address.streetNumber to obtain the value of the street number field for the user Julian, which is 12. Now, the benefit of using variables is that we can update an instance of a case class as easily as we access the data inside it. For instance, we can say julian.address.streetNumber equals 16, and this will modify the street number field to 16, as you can see here. So this syntax, is very concise and easy to understand. So, this seems to be a great option. So what is the problem? Well, the issue is that in FP, we mostly use immutable data. I will quickly go through, the main reasons for that choice. Immutable data offers some nice features like versioning or the possibility to roll back since we never destroy or erase anything. For the same reason, immutable data simplifies testing. We can take an object, apply a few transformations, and then compare the result with the initial state. This initial state is still available and hasn't been altered in any way since the data is immutable. Finally, and most importantly, in a concurrent environment, it's extremely difficult to work with shared mutable data. Either it leads to race conditions, meaning that some threads can access the program in an inconsistent state, resulting in some very tricky bugs. Or we get deadlocks where nothing gets done because all the threads are waiting on each other. While it is theoretically possible to avoid these issues, it's notoriously difficult in practice. I recently watched an interview with Mozilla's Jim Blandy, a co-author of Programming Rust. In the interview, Jim mentioned that an engineer at Mozilla decided to use a thread sanitizer tool to look for data races in their C++ code base. And he found that in every case where Firefox used threads, there were data races. Not just some or most cases, but every single case. Those bugs were, eventually fixed, but it illustrates how difficult it is to deal with shared mutable data. So if we agree we should use immutable data structures, one big question remains: how do we change them? Because, at the end of the day, we need to encode changes in our applications. For example, when we receive a salary, we expect the software that, run our bank account to increase the balance, right? So how do we change something that by definition cannot be changed? I have a short story to illustrate this situation. Imagine you're a developer that lives in an immutable world. And say you're at your desk when you realize that the light bulb is broken. How can you change it? In a normal world, you will just, unscrew it and put in a new one. But here you can't because the world is immutable. Unscrewing a light bulb and putting in a new one is a mutation. So what can you do? You are a clever FP developer, so you have an idea. Let's create a new planet, from scratch, with nothing in it. Then let's copy all the continents, oceans, mountains, and forests. Then let's copy all the cities, roads, and buildings. Then let's copy all the rooms and all the items inside it, including the lamp. And the only change we make is we put a new light bulb in the lamp. Easy peasy. When I heard this story for the first time, I thought it was a joke. Why on earth would you go through so much trouble for such a tiny modification? It turned out that actually it's not that expensive to create a new world and copy everything inside it, because we can safely share the data that hasn't been touched between the different copies of the world. For example, if I change the light bulb in my office in London, I can reuse the African continent from the previous world, since I don't live there. This is called a structural sharing, if you want to Google it. By the way, I would like to thank ImpurePix for making those images, and I encourage you to check out his website, impurepix.com, where you can find lots of FP-related infographics that are both funny and really instructive. You will not be disappointed. Okay, so now if we agree that we need to use immutable data and we need to copy it in order to change it, the next question is, how do we copy things in Scala? Because this is a language we're using. This is where I have 3 examples for you that will be very straightforward. First one, let's go back to our very simple use case where we have a user and an address. But this time, every single field is immutable. Now, how do we change a street number using vanilla Scala? Like a Scala from the standard library. It's actually quite straightforward. We use a copy method from case classes. So we can say, let's take the current user, Julien. Let's call copy, and we specify what we want to change. So we want to change the address. And how do we want to change the address? We take the current address, julien.address, and we copy it and change the street number. And as you can see, it works. So, copy is very simple. It's a bit boilerplatey. But to be honest, if this was the only use case we had of modifying immutable data, then copy will be completely fine. There is no need of something more fancy. The problem is that in reality, we have more complex data. Quite often what we have is enumerations. So let's say now we want to add a payment method to our user. And let's say we only support 2 forms of payment methods: a PayPal account, which is basically an email, or a debit card, which is a card number, an expiration date, and a security code. So enumeration in Scala are encoded using a seal trait, and every class extends this seal trait. But what matters here is that we have either a PayPal account or a debit card. Okay, so now let's update our user. This user will have a payment method. So now I created two users, one called Julien, who has a debit card, and one called Anna, who has a PayPal account. So now the next question is, how do we change the expiry date of the debit card using vanilla Scala? Okay, so first let's try the same strategy. Let's use the copy method. So let's take our current user, we copy it, we change the payment method, and we change the payment method by using copy on it. Fairly simple. Except that it doesn't work, and the Scala compiler rightly tells us so. It says that copy is not a member of payment method, meaning that the method copy doesn't belong to the trait payment method, which makes sense because copy is only available for case classes. So the more general question is, how do we modify enumeration in Scala? And the answer with enumeration is almost always the same. Use pattern match. So now this time we'll look up our current user, our current payment method using user.payment method, and we pattern match on it. And here there are two cases. Either it's a debit card or a PayPal account. If it's a debit card, it's very simple to change it because we can copy it. It's a case class. But what do we do if it's a PayPal account? We are a bit stuck because a PayPal account doesn't have an expiration date. So we can't set this new expiry inside it. And we have to return a payment method because we are within a copy method. So this is the expected type. The only other thing we could do is throw an exception, but this is something we try not to do to avoid in FP. So in fact, here we only have one option, is to return the current payment method unchanged. In other words, if you call update expiry on a user who has a debit card, it will update the expiration date. But if you call update expiry with Anna, who has a PayPal account, it will do nothing. Now, potentially, we could change this method to return an option or an either, but this will require a significant refactoring. So that's why I haven't shown it to you here. Now, I have one last example to slightly complexify this example. Let's imagine our boss comes to us and say, you know what, we actually want our users to have several payment methods. They can have several debit cards, several PayPal accounts, and they can annotate it with a string, with a name, just to make it easy to find them out. So you're like, okay, that's fine. Let's slightly change our user to have this time a map string to payment method. Okay, and let's take a user who has a PayPal account annotated as business and a debit card marked as personal. So now, how do we change the expiry date of this personal payment method? So it's going to be the same, but slightly more complex. Now we'll have to use get from map to look up this payment name inside of the map. Now we have three cases. Either it's none, where this payment name doesn't exist, or it's a PayPal account, or it's a debit card. Now, for the same reason as before, if it's a none or a PayPal account, we can't do anything, so we have to return the payment methods unchanged. But if it's a debit card, we can copy it and update it, and then insert it inside of the map using the method updated. So, this code is not like rocket science. It's not too difficult to write, but it's not pleasant. And it's very low level kind of. And when you look at this method, it's not really clear exactly what is going on. So this is where optics come into the picture. Optics are trying to simplify this use case. So what's an optic? An optic is an interface, a trait, which has two type parameters, a from and a to. So from is kind of a big type, like let's say a user, and to is something within a user, so something we target. So imagine you have an optic called name that focuses into the username. We have three methods. These are the three main methods. So we have get that says, if you give me a user, I will give you back its name. Replace that says, if you give me a user and a new username, I will give you a new user where this new username will be inserted. Everything else stays the same. And modify, which is kind of a convenient method that combines get and replace, that allows us to apply an update function to the targeted field. So for example, here we can uppercase the username. Now you might have heard optic in plural, like optics, and you might have heard that they have fancy names like lenses, optionals, traversals, prism. To be honest, it's kind of a detail. We don't really care about it right now. Why we need several optics is in order to encode different kind of relationship between a from and a to. The main difference is around the get method. Sometimes the get method will return a to, for example, when we know for sure we have the data. Sometimes it will return an option of to when we may or may not have it, or even a list of to when we target several items at the same time. But it's not the most important point. What really matters about optics is that they compose, meaning that if you have an optics from to and an optics from to next, you can kind of squash them together and get an optics from to next, exactly like function composition. And this allows us to drill down inside of an object. Let me show you an example. So here on the left-hand side, I drew a user. So a user has three fields, a name, an address, and payment methods. Payment method is a map, so it has different kind of keys. And you see this highlighted root in this object. This represents an optic that kind of zoom inside an object, the path that it goes through, and you see that it targets the expiration date at the end. And each segment in this diagram represents one optic. So for example, the first segment is called payment methods. So it's an optic that focuses into the field payment methods inside of a user. Then we compose it with the optics index that allows us to zoom inside of a particular key inside of a map. Then once we have a payment method, it can be a debit card or a PayPal account. So we use a debit card optic, which will be kind of a safe downcast into a debit card. So if the payment method is a PayPal account, we'll discard it. And finally, we use expiration date to look up this particular field inside of a debit card. So I really like optics because it's very powerful. You describe a path within your data structure, and once you have this complete path, you can access the data or modify it as you want. It is as simple as that. So now the main question is, why optics are not popular in Scala? Because here I put on the screen the vanilla Scala implementation of update expiry and the optics implementation. I know I'm biased, but I would say that the optics implementation is much nicer. Of course, you need to know about optics and a bit of the API. But once you have done this, the API is quite clear. You see that you define a path within your data structure, and then you call replace to update the expiry. While the vanilla Scala implementation is very much lower level. So why everyone is not using optics in this case? I think there are mainly two reasons for that. I will present you these two problems. First, I think I kind of lied to you because yes, it's nice to have this update expiry function using optics, but you need to define these tiny optics inside it in the first place. They don't come out of thin air. So we need to define payment methods, debit card, expiration date, and indexed. Now you could argue that index is very generic. So it's an optic that focuses into a map. So we can define it in the library in Monocle. But the rest, payment methods, debit card, and expiration date, are optics about your business model. So we can't do anything about it. You have to define them yourself. And to make things worse, each definition of an optic like that is very boilerplatey. It's very boring, and it follows always the same pattern. If you want to create an optic that focuses into a field of a case class, it will be always the same code. If you want to focus into a branch of an enumeration, it will be always the same code. So it's very repetitive. On top of that, you need to know the different kind of optics. So for example, you need to know that payment methods and expiration date are lenses, but debit card is a prism. So if you think about it, from the point of view of a new user of the library, in order to start using it, you need to define tons of boilerplate code and you need to learn a lot of things about the internal of the library. So it's very discouraging. So in Monocle 2, so the current version of Monocle, what we did is that we defined a couple of macros to simplify the creation of optics. So we have GenLens, GenPrism, GenISO, and which simplify the code. You still need to define them in the first place, but at least the implementation is much shorter. And this is where macros are already made for. When you have code that is completely stupid, completely repetitive, macros are exactly made for this use case. The main issue remains is that you still need to know the underlying optic, which optic do you need for each use case, which is annoying, especially for new users. So for the next version of Monocle, we had an idea to create one macro to rule them all, and we called it focus. So focus is going to work very similarly to GenLens. So you first specify the type you want to start your optic. So in this case, you want to start from a user, and then you define a path within your data structure. So you can say ._, .address, .street number. And your IDE will support code completion out of the box. And in this case, it will generate a lens. As an end user, you don't need to know that it's a lens. The compiler and the library will tell you that, and you can just use the method available on lenses. If you decide to zoom inside of a map using, for example, index, then in this case, it will return an optional because potentially this data may not be there. But again, you don't need to know about it. The library and the macro will let you know. So I think this is great. Like as a new user, you will be able to write optics out of the box. It will be supported by your IDE, and it will be very simple, very concise. We even plan to add some kind of cute operators, not many, but a few. For example, asterisk will mean that you zoom into every single item inside of a map or inside of a list. We may add also like question mark to zoom inside of an option. These operators are very common, and you can find them in other libraries like XPath or other kind of technologies. So I think this is good because it will make the code of complex optics very concise. So it's great for power users, but it's even better for beginners because it can take the normal paths that they know in other kind of language and reuse it straight away in Scala, and it will be supported by the compiler. So I'm really, really excited about this focus macro. And I would like to thank Yiling Wei, who prototyped an early version of Focus inside of Monocle. So Monocle is a repository, a playground we are using to prototype ideas for Monocle with Scala 3. So Focus will only be available for Scala 3 because Scala 3 has a completely new macro system, and it will be like too expensive to try to do it in Scala 2. Okay, so this is the most important point. Now there is another point I would like to bring, like why optics are not popular. And this point is much more subtle. So it's about lawfulness. I hate that word, lawfulness. If you have been teaching Scala or functional programming for a while, most likely at some point you told someone like, you can't do that, it's unlawful. And most likely at that point, the person in front of you like laugh and say, what do you mean it's unlawful? Is there is a kind of like secret lambda police that will come to me and put me in jail because I threw an exception? No, that's not what people mean. It's just an unfortunate name. It means that we are dealing with interfaces, and these interfaces have an expected behavior or contract. And so we just want this contract to be satisfied. And let me show you in practice, what does it mean? So let's say we create an optic that focuses from a user to the street number. Let's say, for example, using the focus macro. Now, if you use replace, you will be able to change the street number to 48. You see, like before it was 12, now it's 48. Perfect, it works. But how do you check that it works? You could write a unit test, but this would be very specific to this particular optic. Another way to do this is because optic has a get method. So why don't we use it in order to call get on the updated user, and we'll verify that we get back the same data that we just replaced. This will be the most standard behavior, the least surprising behavior for an optic. And we can automate this process using property-based testing. With property-based testing, we can generate a random user, a random street number, and do this operation, replace and get, and verify that we get back the same thing. And functional libraries like Monocle, they package all these properties in a module and offer it to the users. So like this, you don't even need to know that they exist. When you create your own optics, you can just run the test suite and you can check if your optics you just created is valid. So it's very convenient. And there is a FP library design principle that says that when you create this interface from scratch using like a very low-level constructor, it's up to you, the user, to verify that the optics you just created satisfy the expected behavior. So in concrete terms, it means you need to run the test. You need to verify that they are correct. It's your responsibility. But FP libraries, the very nice feature that they tell you is that once you've done this job, once you have solid foundations, if you combine these optics together using functions we provide in the library, then you're guaranteed that these optics will be correct by construction. This is a very nice property because it means you can trust, you just need to verify the bottom layer and everything else you build on top of this will be safe. So this is a great property. The problem is that sometimes we have some combinators, some methods that can potentially, in very weird cases, break the test. So let me show you an example. Zip. So zip is a combinator, a method on an optic that zip two optics that starts from the same type. So imagine you have an optics from a user that focus into the username and another optics from a user that focus into the street number. When you zip them together, you focus both at the same time into the street number and the username. And it does what you would expect. If you call get on it, it will give you back a tuple Julien 12. And if you call replace, you will change at the same time the username and the street number. So it's very convenient. It's been years, and users of Monocle have been asking us, can I get zip in the library? And so far, we have always refused because there is a tiny chance to make that zip is unsafe. Let me show you where. So imagine you create an optic called name that focuses into the username, and you zip it with itself. Now, there is no reason, no use case for doing such a thing, but you can. There is nothing blocking you from doing it. Now, what happens if you do it and you call replace? You will specify two strings. You will say, okay, Bob and Alice. But there is only one username, so we can only select one of these. So we'll create, let's say, a new user with only the last one, Alice. But the problem is once you call get on this updated user, you will get back the tuple Alice Alice because this is the current username. So in other words, in this very weird use case where you will zip the same optics together, you break the properties that you should get what you just replaced. Now, this is very unlikely to happen. There is no reason for it to happen. But because it is possible in Monocle, we said, okay, we don't want you, it's too risky, you could potentially hurt yourself. We're not giving it to you. I think this is why in FP, we have this reputation of being on top of an ivory tower. I think it's very condescending to our users to say that there is a tiny chance that you screw up, so we're not going to even give it to you. I think if something is useful, and there is a tiny chance that there is an issue, we should offer it to our users and just document it. We'll use a Scala doc, we'll use blog posts, we'll use our website to document this use case. And probably some people will get it wrong, but it will happen once or twice, and then they will learn the lesson. But zip is very useful, so we should offer it to our users. Okay, so to summarize, Monocle currently has a steep learning curve and a lot of accidental complexity. In my opinion, these are the main reasons why optics are not mainstream in Scala. In the upcoming version of the library, our goal is to focus on improving user experience and making it more friendly for beginners. First, we'll implement a unique macro called focus, which is in charge of generating the right optics for a given path. This should simplify a lot the onboarding process, offering an API that is very similar to what people are used to coming from XPath or jQuery. Next, we'll adopt a softer stance with regard to the so-called laws. This means that if we find a useful combinator that can potentially be misused, we'll add it to the library, but we'll try our best to document how to use it safely. In practice, this means we'll add new powerful methods like zip, filter, or with default that were previously rejected from Monocle. And there are lots of other features that we have in the pipeline, but this will be the subject for another talk. On that topic, we do have lots of work in front of us and very limited resources. We share the same problem that most open source libraries have. We have dozens, if not hundreds of companies using our code, but zero financial contribution. Now, I'm not expecting that to change in the near future, but I will really appreciate it if more people will take the time to contribute, and ideally during your office hours. You don't need to be an expert in optics to join the team, and you don't need a PhD in category theory either. We are more than happy to mentor you and fill any gaps you may have. But we also need help with other topics, such as the build tools, technical writing, testing. Even commenting on PR and tickets is a huge help. So don't hesitate to reach out to me or any other maintainers, and please join our Gitter channel. So I think I have a minute or two left, so I would like to briefly present my course, Foundations of Functional Programming in Scala. It's a self-paced online course that focuses on the practical side of functional programming. It's not about the fancy type-level things, but the down-to-the-earth FP techniques that allows us to write robust and easy-to-maintain applications. The course has no prerequisites other than basic understanding of the Scala syntax. So it's a perfect fit for a new Scala developer or someone with an intermediate level, but who wants to fill in some gaps in their fundamental FP skills. So if this sounds like something you might be interested in, you can find more information on the course webpage, or just send me a message after the talk. I also created a 15% discount code for people attending the conference using the coupon SBTB15. So don't wait too long because this offer is only valid for a week. So thank you everyone for attending this presentation, and I hope I will see you soon in the Monocle Gitter channel. Cheers.